Say, Bob, where did you get that pump? It doesn't look like any of those I've seen you working on before.
This is one of those new roller-type pumps, Joe. A few of them were used on 1968 cars, and I understand a lot more of them will be used on this year's cars.
This new pump has a lot of good design features, Joe. Besides, it's an easy pump to service, and more service parts are available for rebuilding it than most of the pumps we've used on our cars.
Do you suppose you two could take time to fill me in on this pump? I like to keep up on any new stuff that comes along.
Oh, I guess we can spare a little time for a young fella that's eager to learn. How about it, Bob?
Sure thing, Tech. As a matter of fact, I finally figured out exactly how this pump with its combination flow and pressure relief valve works myself. Tech can check up on me to see if I have everything figured out right. To begin with, this new pump gets its name from the 12 steel rollers that fit into V grooves in the rotor. These rollers replace the slippers or vanes used in the other type pumps. The rotor is driven by the pump pulley, and the rotor and rollers rotate inside an elliptical cam ring. When the pump is operating, centrifugal force moves the rollers outward against the cam. Now notice, this pump has two pump inlets. The two inlets are opposite each other, where there is a lot of room for incoming fluid in the space between the roller, the V groove, and the cam ring. This is where the intake or low pressure ports are located. There are also two outlet or discharge ports. At these outlet pressure points, the cam ring pushes the rollers into their V grooves. The rollers literally squeeze the pump fluid out of the V grooves and into the pump discharge ports.
Since the two pressure chambers are directly opposite each other, they balance out the radial loads on the rotor. As a result, there are no hydraulic side loads on the pump shaft and bearings.
It sounds like this should be a real good pump, but tell me, is there something special I ought to know about servicing it?
The servicing instructions in the manual are complete and easy enough to follow. However, there are a few precautions that are especially important. For instance, be sure and use this special puller to remove the pump drive pulley. It'll make the job easier, and you won't damage the pump or the pulley. Pump disassembly is simple if you know how to go about it. Remove the reservoir and clamp the pump body in a vise with soft jaws, pump shaft down. This will make it easy to get at the end cover retaining ring. Here's the trick in getting the ring out of its groove. Tap the end cover retaining ring around in its groove until one of its ends is opposite the small hole in the pump body. Use a pin punch to push the end of the ring out of its groove, and the rest is easy.
A couple of changes were made in the pump after the 1969 service manuals went to press, so we'll pass on the latest pump assembly tips and precautions. You'll find it easier to assemble a pump if you put the dowel pin in first, followed by the seal plate gasket and the seal plate. Make sure the cutout sections of the gasket and plate face the intake ports in the pump body. You'll find the latest information on servicing early production pumps with round seal plates in the reference book. When you assemble a thrust plate, make sure it goes into the bore chamfered edge first. And of course, the index notch of the plate must line up with the dowel. The machine notch in the cam ring must go up. Some cam rings have only the machine notch. Others have a formed notch in one face and a machine notch in the opposite face. After the rotor and rollers are positioned in the cam ring, lubricate them with power steering fluid. Then spin the shaft to position the rollers properly. If the rollers were cocked, they would interfere with the assembly of the pressure plate. Before you install the pressure plate, make sure the end of the dowel pin is 3/16 of an inch above the cam plate. Line up the index notch with the dowel pin. As a final check, look through the pressure ports. You must be able to see all 6 holes in the cam ring, 3 through each port opening.
Be sure and seat the pressure plate against the cam ring. If there's any excess clearance between the cam ring and the pressure plate, the pump won't develop pressure because it won't be able to prime itself. With this new pump, you don't dare press the pulley onto the shaft, or you'll push the pressure plate away from the cam ring. If that happens, the end cover spring isn't strong enough to reseat the pressure plate and the pump won't prime.
Even a good bump on the end of the shaft will unseat the pressure plate. That's why it's so important to use the special pulley installing tool. You'll find all of the service details in your service manual, so be sure and use it.
Well, tell me, Tech, which pump parts are serviced?
In addition to the partial pump assembly, which includes everything except the reservoir and pulley, there's a sealed package and a rotating parts package. And now let's talk about our new two-stage flow valve. Some of our competitors get by with a single-stage flow valve, but a two-stage flow valve is a good feature, and here's why. At low engine speeds, particularly when parking, the power steering pump must provide high flow so that gear demand won't be greater than pump output. At highway speeds, the flow from this same pump would go sky high at the very time when the flow demand of the gear was low.
Why is that bad?
Excess flow heats up the fluid and wastes power. A two-stage flow control valve provides ample flow for full assist at low engine speed and then reduces flow to the amount needed at higher speeds.
Well, just how does a two-stage flow control valve work?
This cross-section helps explain it, Joe. At low engine speed, the entire flow from the pump goes from the pump pressure chamber to the pump outlet and is supplied to the steering gear. That's because the pump bypass is closed off by the flow control valve. Now notice, there's an orifice in the passage leading directly from the pump pressure chamber to the pump outlet. You'll also notice that there's a second orifice and flow path that leads into the spool valve bore and then to the pump outlet. Also, if you look real close, you'll see that there's a small passage through one end of a spool valve. This is a pressure sensing port for the chamber at the spring end of the spool valve. Are you still with me?
So far, so good, Bob.
As pump speed and flow increases, pressure builds up at the plug end of the valve. However, there's a pressure drop at the two orifices. Because of the sensing port, there is also a pressure drop at the spring end of the valve. As soon as the pressure difference between the two ends of the valve is great enough to overcome the spool valve spring, the spool valve moves far enough to uncover part of the bypass passage. Flow is reduced because part of the pump output is returned to the pump inlet. At still higher speeds and lower gear demand, the pressure difference moves the valve even more. One flow path to the pump outlet is blocked completely. The additional pressure drop at the spring end of the valve causes it to move even more, uncovering more of the bypass. With the valve in this position, most of the pump output is returned to the pump inlet. Only the flow required for normal highway driving is supplied to the gear. There is no waste of power or unnecessary heating of the fluid.
Where's the pressure relief valve for this pump?
It's hidden right inside the flow valve, Joe. It's actually a triggering device that causes the flow valve to limit pressure. Here's how that works. A spring-loaded ball-type pressure relief valve in the spring end of the flow valve is normally closed. As long as the pump pressure doesn't exceed its rating, the pressure relief valve doesn't affect flow valve operation in any way. However, suppose the front wheels are turned hard over against their stops. When pressure builds up to rated maximum at the spring end of the flow control valve, it unseats the relief ball and fluid is dumped into the bypass passage. When this happens, there is flow through the sensing port in the spool valve. When the relief ball pops open and there is flow to the spring end of the valve, the sensing port becomes a pressure controlling orifice. The pressure drop across this orifice determines valve position necessary to maintain rated pump pressure. This setup is called a trigger-type relief valve. Unseating the relief ball doesn't provide enough flow to relieve pressure. Instead, the pressure drop across the trigger orifice makes the flow valve double as a pressure control valve.
The complete flow valve assembly is selectively fit to its bore in the pump housing. For that reason, the valve isn't serviced separately, and the flow valve from one pump must not be used in another pump. The valve can be removed and cleaned, but the separate parts are not serviced. Shims are used to determine the pressure rating of the pump. When you clean a valve, save the shims so they can be reassembled after the valve has been cleaned. Do not change the number of shims.
This new pump is supplied in 3 different pressure ratings, depending on car model application. If you replace a pump, be sure and get the correct part number. And now, if you turn the record, you'll be able to hear what we're going to tell Joe about power steering gears. Mechanically, there's very little difference between a power steering gear and a manual gear. Even if something happens to the hydraulic part of the power steering system, you still have mechanical control of the car. But suppose we let Bob explain gear operation.
That's my specialty, Tech. Turning the worm shaft of a power steering gear moves the power piston up or down in exactly the same way that the worm shaft in a manual gear moves the ball nut up or down. The cross-shaft sector teeth engage rack teeth machined into the power piston. This arrangement changes up and down piston movement into cross-shaft rotation. Again, this is essentially the same as a manual gear. And as you already know, the cross-shaft moves the pitman arm in an arc, and this motion is transmitted to the front wheels through the steering linkage. From steering wheel to front wheels, the mechanical operation is the same for power and manual gears. However, in a power steering gear, the steering gear housing is also the cylinder for the power piston. The power piston divides the cylinder into 2 separate power chambers. But we'll have to look at the gear from another angle to see how pressure in these chambers is controlled. The steering valve, mounted on the gear housing, determines whether pressure will be routed to the power chamber above the piston or the chamber below the piston.
But what controls the steering valve?
A pivot lever is the mechanical link between the steering valve and the worm shaft reaction area.
That reaction part of the gear's where I get lost.
Okay, my boy. Let's see if Bob and I can explain it slow and easy so you'll get unlost. We'll use a gear with a left-hand worm. In a right turn, the worm shaft tries to thread its way out of the power piston. As a matter of fact, the entire worm shaft does move upward a very small amount. Can you explain why, Bob?
Sure thing, Tech. The worm shaft thrust bearings and center race are between the cylinder head and the housing head. But there's enough clearance between the cylinder head, center race, and housing head to allow the center race and the worm shaft to move up or down a small amount. So, when the steering wheel is turned to the right, the worm shaft and thrust bearing moves upward. By the same token, on a turn to the left, it moves downward. This thrust bearing movement is used to operate the steering valve. Here's how. The steering valve spool is connected by a pivot lever to the center race of the worm shaft thrust bearing. A ball shape at the upper end of the pivot lever fits into a pocket in the spool valve. The lever pivots on another ball shape and is connected to the bearing by a ball at the lower end of the lever.
It doesn't take much movement of the center race to move the steering valve spool quite a lot. Since the part of the lever above the pivot is about 4 times as long as the part below the pivot, the lever multiplies center race movement about 4 to 1. Well, that just about wraps up the mechanical connection between the steering valve and the worm shaft. Unless you have a question, we'll get into the hydraulics.
I'm all ears, and you haven't lost me yet.
Lands on the sliding spool in the steering valve open or close the ports leading to the power chambers above and below the power piston. As long as the spool valve is centered, both power chamber ports are open the same amount. Pressure is equal in both power chambers and there is no power assist. On a left turn, the worm and center race move downward. This moves the spool valve upward. The lower land closes the lower port to pump pressure and opens it to return flow. The pressure in the power chamber above the piston is reduced. At the same time, the upper land of the spool valve opens the upper pressure port even more. This admits full pump pressure to the power chamber below the piston.
Since there is full pressure below the piston and reduced pressure above the piston, hydraulic pressure pushes the piston upward. This power assist continues as long as the driver turns the wheel and keeps the control valve off-center. When the steering wheel is turned to the right, the control valve moves down instead of up, and the entire power assist process is reversed.
I can understand that easy enough, but the reaction rings and the built-in feel still stump me.
Bob kept it simple on purpose. But now I think you're ready to hear about the reaction springs and the reaction rings. So let's go back and take a closer look at the pivot lever and the center bearing race. The center race, a spacer, and the pivot are actually sandwiched between the reaction springs and the reaction rings. But let's see how this looks in a cutaway illustration.
The reaction springs provide the basic centering force acting on the center race of the thrust bearing. When turning force on the steering wheel is relaxed, the reaction springs center the bearing race, and this returns the steering valve to the neutral position. You'll notice that the reaction springs do not bear directly against the center race, but bear against the reaction rings, which do bear against the center race. The reaction springs provide part of the very desirable feel built into the gear, but not all of it. It is the reaction rings which provide the resistance or feel that is proportional to the total steering effort required to steer the car. The resistance of the reaction spring is always the same, but the resistance provided by the reaction rings depends on the actual steering effort called for. Hydraulic pressure from the lower pressure chamber acts on the lower reaction ring. Pressure from the upper power chamber acts on the upper reaction rings. However, when the steering wheel is turned and the steering valve is moved off-center, there is more hydraulic pressure against one reaction ring, less against the other. This extra pressure resists steering wheel movement to provide excellent steering feel.
Why are there two reaction rings above the center race?
The two upper reaction rings correct an inherent unbalanced hydraulic condition in the steering gear. If it weren't for the extra reaction ring above the center race, the car would try to self-steer to the right.
You'll find a detailed explanation of those unbalanced forces in the reference book. Before we sign off, let's see what tips Bob can give us on power steering diagnosis.
The first step is to figure out whether the trouble is in the pump or the gear. If there is no assist in either direction, the trouble is probably in the pump. At least it is probably lack of pressure or flow. The obvious things to check are belt tension and fluid level. If the trouble is in the pump, the first thing to check is the valve. Remember, if the valve sticks, it will stick open. That's because pump pressure opens it and spring pressure isn't great enough to close it if it's dirty or burred. Foreign material in the gear or pump is the greatest single enemy of the power steering system. It's impossible to overemphasize the importance of cleanliness when servicing the pump or the gear. The only safe way to remove scratches or slight burrs on the valve spool is to carefully rub the spool against a piece of crocus cloth laid over a flat surface. Remember, that spool is a selective fit in the pump body, and all you want to polish out is the burred metal. Self-steering, or unequal assist, on right and left turns is most apt to be the result of control valve sticking or of misadjustment of the valve. To adjust the valve, I simply jack up the front of the car so the wheels clear the floor. Then I back off the steering valve body screws and retighten them to about 7 foot-pounds. With the engine running, tap the steering valve assembly up or down until there is no self-steering. Then, tighten the valve body screws. Don't turn the front wheels against their stops before you retighten the valve body screws, or you'll blow out the O-rings. When adjusting the valve, tap the control valve body screws to move the valve up, the end plug to move it down. Do not tap on the control valve or the steering valve body. Lumpiness or binding is usually not in the gear, but in misalignment of a steering column. Whatever you do, don't force the floor plate in order to start the plate attaching bolts. If you follow the procedure in the service manual, you won't have any trouble on this score. The lower end of the steering shaft must be centered in the coupling so that the gauge hole is 13/16 of an inch above the coupling. An uncentered coupling can cause lumpiness, wander, and returnability problems.
I'm sure glad I asked you about that new pump. I wound up getting a liberal education on pumps and gears.
You'll find some additional information on diagnosis and service in the reference book, Joe. I hope you fellas out there will give your reference books the once-over now and keep them handy for future reference. And don't overlook the information in your new service manuals. They have all the service details on the new pump.